How did you find the first session? For those who attended or for those who watched the discussion class, how did you find the first session number 1? And then the second question is, did you go back and read? Those are the two questions. How did you find the first session? Guys, remember it's a discussion class. You keep quiet, I keep quiet. And then we'll just... helpful. Thank you. You can be honest, guys. If you find it not okay, it's fine. And then others found it helpful. And yeah. Another person? Okay. And then now, did you go back and do the exercises? Like, did you practice? Because it becomes more and more difficult the further you go, because then there are long steps. Did you practice all the questions? Guys?
Yes.
Yes.
And then, okay, thank you. And then the other thing, did you go back to assignment 1? Remember what I said? We attend class, you go and practice, you go back to assignment 1 and see which question you can attempt. You do that every time. You attend class, go back to the question. I mean, what's this? Do all the exercises there. And then if you have a question, send me an email using your My Life email address. And then we address the question. And then you go back to your assignment and see which question you can attempt. I hope that's clear. So now today's session, let's start today's session. But before we start today's session, I hope you remember we did what's this? We did some sums of functions, how to differentiate sums of functions. We then looked at the product rule. We then looked at the chain rule as well as the quotient rule. We do remember those ones, isn't it? Yes, no?
Yes, ma'am.
Thank you.
Yes, ma'am.
One last yes, please. Thank you. So now, today we are on page 24, logarithmic differentiation. So there's a summary of facts that is on page, what's this? On page 24, where it says the definition. So the logarithmic of a number is the power of which the base must be raised to the number. Thus, if x is equals to a to the power of n, then we say n is the log of x, then to the base of a. So that is, they're saying that. So there has always been a relationship between the exponent as well as the log. So meaning that if you write, so this is in a form of, this is an exponent, right? X is equals to a to the power of n. Now, how do you write it in a log form? So this will then be n is equals to log of x base a. Are we all together? So this is in a log form, and this is the exponent form of this particular log form. Now, and then they say change of base. To change the base from a to base b, we use the relationship. So that's the relationship that they are going to use there to change. So log of a base b is equals to 1 over log of a base b is equals to log of what? Log of log of b base a. Are we together so far? Now, then they say the logarithm of a number of base e, meaning that if you have a log of any number n to base e, then that is just equals to ln of n, which we call the natural logarithm. Hey, yeah. Are we all together thus far?
Yes, ma'am.
Yes,
ma'am.
Now, these are the three important. They even wrote the three important. Guys, please help. Let's admit the others. But they need to be reminded that next time we won't admit them, they should use their My Life email address. So these are the three important laws that we need to know, right? They say if you have log of A times B, this is the same as log of A plus log of B. And please note that A and B both should be greater than 0, meaning A and B should both be positive, because the log of a negative number is undefined. Now, log of A over B is the same as log of A minus log of B. Then the last one that we're going to use, so this is 1, this is 2, this is 3. So log of A to the power of n is the same as n to the power of log, is the same as n times log of A. You see this? Look at it. I'm going to give you 2 seconds, 3 seconds to look at it, understand it. If you have a question, ask me before we actually attempt. Are we looking at it? Is there any question? Is there any question? Going once? Going twice? Okay, let's move on. Now, this, what's this? Logarithms, right? In our case, we are going to use, remember what we said? We said log of n, which is any number, base e, is equals to the ln of n. So when we're going to do logarithmic differentiation, we are going to use this ln of something. In this case, what is this ln of something? It's called the natural logarithmic. And it also has the same properties as the log function, meaning that the ln of A times B is equals to ln of what? Of A plus ln of B. Number 2, the ln of A over B is equals to ln of A minus ln of B. Number 3, the ln of A to the power of n is equals to n times ln of A. Are we recording the session? Yes. Okay, are we all together there?
Yes.
Thank you. Can someone tell me why are we talking about this natural ln in differentiation, and when do we use it? Can someone try? When do you think we use this logarithmic differentiation, or we just use it when we feel like using it? Remember, I said you need to be able to identify when to use it. When do we use it? Can please someone try? Remember, I said
when there are more than 2 functions, ma'am.
Wait. When there are more than 2 functions, wait.
Yes, ma'am. In either the numerator or the denominator.
Only that case. That's one of the cases. That's one of the cases. Another case. So let's say there are 3 cases. Another case.
Maybe when we need to do implicit differentiation.
There, but not there. Because then logarithmic differentiation has some implicit differentiation in it. Has some behavior. Let's call it behavior of implicit differentiation. And what is, just a reminder, What is the behavior of that implicit differentiation? When we differentiate implicitly, what happens to what? That's small behavior.
We have to differentiate the y as well.
Yeah, so when you differentiate y, what do you do? After differentiating y, what do you do?
Well, we'll have to put y back into the equation at the end.
Yes, but you said when differentiate y. Remember, when we were differentiating x squared implicitly in, let's say, as an expression, we just say 2x. But when we're differentiating y squared, what did we do?
We add the dy dx.
Thank you. We multiply the dy dx. So then this will be dy times dy over dx. So that's the implicit behavior that we're also going to get in the logarithmic differentiation. Now, okay, so there are three cases, let's say common cases at which you can use to differentiate using logarithmic, right? Remember when we were doing the product rule, we said the reason we call it the product rule is because we are what? We are differentiating two functions. Isn't it? Not really differentiating in two functions, but we're sorry. The reason why we call it the product rule is because we're finding the product of functions. Now, in our previous section, we had only two functions. We had f of x and g of x, right? And then when we're doing the quotient rule, we had f of x and g of x. Now, there on page 24, it says the rule for differentiating a product for a quotient rule that we have used up to now are applied when we are dealing with two-factor functions like this, right? Or we are dealing with f of x over g of x. When there are more than two functions in any arrangement, are we together? Guys?
Yes, ma'am.
Are we together? When there are more than two, meaning that, okay, fine. With product rule, you can have three functions, f of times g of x times h of x, right? But the thing is, sometimes it becomes difficult to differentiate such an expression. Or if you have f of x times g of x over z of x times h of x, then it becomes difficult for you to differentiate such expression using the quotient rule. So now to simplify this differentiation, what are we going to use? To simplify this differentiation, we then use the logarithmic rule. Are we all together? Or should I give an example?
Example.
Yes, please.
Okay, so remember with our product rule, we said that let's say we have y is equals to x squared over sine x. Do you see that the top function is just f of x is equals to x squared, right? And the bottom function is just g of x is equals to sine of x. What happens if we have y is equals to x squared times sine of x times cos of x over tan of x times, let's say, sine of 2x? What happens if you have that? Is this easy to differentiate? Which one is easy to differentiate, number one or number two, using the quotient rule?
Number one.
Guys, which one is
Number
easy
one.
to differentiate? Do you see that? Now with number two, it's not impossible to differentiate. It's just not easy to differentiate, because remember with the quotient rule, you have to differentiate. At some point you have to differentiate this, and some point you have to differentiate that. And imagine here there's already a product rule, so you then have a long step with a long whatever and whatsoever. That is why we then go for logarithmic differentiation when it comes to such an expression. Are we all together now?
Yes.
I need, you know, I work with 3 yeses. If there's a no, it cancel all the yeses. One that's yes.
Yes, ma'am.
Yes, ma'am.
Thank you. So meaning that we are going to go back to our assignment and see if we have some form of similarities to what we just talked about. Are we okay?
Yes, ma'am.
Yes.
So now
Yes.
let's say in our assignment we have y is equals to x squared sine x. This is example 1 on page 24 cos 2x. Here I'm going to use the quotient rule or the logarithmic differentiation. If the quotient rule tell me y, if not the quotient rule tell me y. If the logarithmic differentiation tell me why or why not. By looking at this, what are we going to use?
We
An
are going
easy
to
way.
use the logarithmic differentiation
Why?
because at the top we have two functions.
Thank you very much. At the top, we have two functions. I'm not saying don't use quotient rule, but what we are saying is if you use quotient rule, it will make your life difficult. You have a lot of expressions, and at some point you'll be stuck. At some point, you won't even get to the final answer. But we want a easier method. If you are not told which method to use to differentiate, then use the one that will make your life easy. So how does this logarithmic differentiation work? The first step, right? We learn both sides. We take the natural log both sides, right? So meaning that we learn this side and take the ln of this whole function, squared sine of x over cos 2x. Are we all together there?
Yes.
That's the first step. Guys, when you write, don't write first step. We're just doing for now, right? Second step, simplify. Using the laws. Let me write on page 25 and the ones that you learned previously in previous grades. Simplify using the laws. The laws of logarithmic. Which law are we going to use here? So let's simplify the right hand side. Simplify, let's say the right hand side, meaning this side here, in this case, right? Because it's the only one that needs simplification. Let's simplify, guys. Which law are we going to use here?
It's going to be ln x squared plus ln sine x minus ln cos 2x.
Is there anyone who doesn't understand how she got it? Guys, remember, everyone is writing the exam individually and you are being invigilated. So if you don't understand, tell me now. Unless there's someone paying for your fees here who doesn't want you to talk. Is there anyone who doesn't understand? Should I explain step by step on how she got the answer?
I understand, ma'am.
Anyone else? Number 2?
I understand.
Number 3?
Understand, ma'am.
Okay. So, okay, let me just explain. Now, the first thing here, we see it's this over that, isn't it? That's the first step. Are we all together? Yes or no? This function
Yes.
over that function.
Yes,
Thank
yeah.
you. So meaning that this will be ln of y is equals to, let me just write it here. So it's x squared sine of x over cos of 2x. So we have the top and the bottom. And according to the properties, the laws that we have on page 24, it says if we have ln of the top over the bottom, this is just equals to what? Ln of A minus ln of B. Are we all together there? So meaning that this A is the top, our top is this. So this is ln of x squared sine of x minus ln of cos of 2x. Are we all together there?
Yes, ma'am.
Okay, good. Now, are we done simplifying? No, because there's another law that says if you're multiplying ln of A times B is equals to ln of A plus ln of B. So meaning that here we have x squared times sine x. So this will be ln of x squared plus ln of sine x minus ln of cos 2x. Are we done? No. This part is a problem as well. So let's deal with it. Back to page 24. There's a property that says if you have ln of A to the power of n, this is n ln of A. Did you see we applied all the properties there? So then this will be equals to 2 ln of x plus ln of sine of x minus ln of cos of 2x. Are we all together there?
Yes, ma'am.
Good.
Yes.
Okay, in the textbook they didn't simplify it, but it's fine. We simplified further. Okay. Let me look for a new page. So we are at ln. Okay, my pen is changing. Sorry about that. Are we all okay with the green color, guys? Can we
Yes,
see?
ma'am.
Okay. So ln of y, we said is equals to 2 ln of x plus ln of sine of x minus ln of cos of 2x. Are we done simplifying? Is there any other rule, log rule can we use here? Is there a rule on page 24 that we can use here? 3 important laws of logs. Is there any? Yes, no? Guys?
No.
Okay. It means we
No,
are
ma'am.
done. Thank you. It means that we are done simplifying, so we can then continue to differentiate, right?
Yes.
Now, from the standard laws that we learned previously, because you guys said you practice, we know that if we are given y is equals to, okay, y is equals to ln of a function of f of x, dy over dx is equals to 1 over f of x times the derivative of f of x. Are we all together? Do you remember that?
Yes.
Thank you. And we said f of x is the inside function and the outside function is ln of x. Are we all now comfortable with the inside and outside function?
Yes, ma'am.
3 yeses, please. Last yes.
ma'am.
Thank you. So meaning that now we need to differentiate. So according to the standard rule of differentiation, this one over here, which is also on page something previously in our previous session, we differentiate both sides. So we start differentiating this ln. So this ln will be 1 over y, 1 over the function times the derivative of function. In this case, the derivative of y is just 1. Since we differentiated y, we said we multiply by dy over dx equals to, now we have 2 ln of x is 1 over x times the derivative of x, which is 1. Okay, plus this one now. Differentiate that. This is 1 over sine inside function times the derivative of the inside function. It's cos of x minus the derivative of this. So this is minus 1 over cos of 2x times the derivative of cos of 2x will be minus sine 2x, but sine also has a what? A function inside here. So that is differentiate that inside function, that is times 2. Are we all together there?
Yes.
I only
Yes.
had what is 2 years.
Yes, ma'am.
Yes.
Thank you. So let's simplify. So now this is 1 over y times dy over dx equals to 2 over x plus cos of x over sine x plus 2 sine of 2x over cos of 2x. Are we done? No, we're not done. So we multiply y both sides. So this is dy over dx equals to y. Be careful. You multiply the entire thing, meaning this entire thing. So this is 2 over x plus, we know that cos over sine x is what? It's cot
What?
of x plus this is 2 tan 2x. Are we done? No, we're not done. Because we multiply by y, and we know that y is given there. We know our y is given initially, that our y is equals to x squared sine of x over cos of 2x. So then we substitute it back here. So therefore, your dy over dx is equals to x squared sine of x over cos of 2x, 2 over x plus cot of x plus 2 tan 2x. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yes.
Thank you. Now, another way of identifying when we use logarithmic differentiation. Do you remember what a variable is? What is a variable? Variable. What is a variable? If we have an expression y is equals to 2x squared, which one is a variable in this function? Let's call this f of x. Which one is a variable? Guys, which one is a variable? Do you remember what a variable is? Okay, which one is an exponent? Which one is a coefficient? Which one is a variable?
I think x is a variable.
Why?
Because 2 is a coefficient, and then 3 or 2 is an exponent. Then x, then 2, then x2 is a coefficient of this variable of which is the x.
Why do we call it variable? I like because you guys know what you're talking about, but you don't understand what you're saying. They didn't tell you why they called it a variable. Because it varies. It doesn't have a constant number. So if you say, let x be whatever, you're giving it a value. But then if it's just x, then it varies. It changes. X can be any number. As soon as you say x is any number or y is any number, then that is a variable. Variable. However they call it. So now, another way of, remember that normally we'll have y is equals to x squared, isn't it? And then we differentiate dy over dx is equals to 2x, right? Now they're saying you can use logarithmic differentiation if you have a power of a variable or a function. Does it make sense?
Yes, ma'am.
Meaning that if you see something in your question that has an x to the power of y, or an x to the power of x, then you know you have to use logarithmic differentiation. Unless they tell you do not use logarithmic differentiation. I don't know how they want you to differentiate then. Are we all together?
Yes, ma'am.
So now I need a different yes. 2 yeses. 2 more yeses.
Yes, ma'am.
1
Yes,
last
ma'am.
yes. Thank you. So you go back to your assignment and see if what we have learned today, learned last week, is there any question you can answer? Then we move on until we finish that assignment and get total. So there's an example. Y is equals to x to the power of 3x. Now we can see that this is a function. 3 and x is a function, meaning it's a variable to the power of a variable. So therefore, you can't use your standard differentiation of saying x to the power of n when differentiated is nx to the power of n minus 1. So therefore, you have to use logarithmic differentiation. So let's do that. We learn both sides. X to the power of 3x. And then we simplify, ln y. Now this rule, we know that if we have ln of a to the power of n, though this is n ln of a. So let's use that rule. So this is 3x ln of x. Now differentiate. So differentiate both sides because we are done simplifying. So this is 1 over y times the derivative of y, which is 1. Because we differentiated y, it's a crime. So we multiply by dy over dx. Now here, how do we differentiate? What rule are we using there?
We use a product rule.
Thank you. Because it's the product of two functions, f of x times g of x, where f of x is equals to 3x and g of x is equals to what? Ln of x. Now, what is the product rule? Just a reminder, one last reminder, and I'm not reminding you from next week. We'll just say product rule. So first differentiate the first function, leave it the second function the way it is, plus differentiate, leave the first function the way it is, and differentiate the second function. So from next week, when we say product quotient, we're not going to look at formulas. We're just going to move. So meaning that we say we first differentiate the first function. In this case, our first function is 3x. So the derivative of 3x, we know is just 3. Then we leave the second function the way it is, ln of x. Plus, we leave the first function the way it is, 3x. We differentiate the second function, so that is 1 over x times the derivative of the inside function, which is x, so the derivative of x is just 1. So then we have 1 over y times dy over dx, so this is equals to 3 ln of x plus 3x over, is it 3 over x? Yeah, x. So then this is dy over dx. So this is equals to y, 3 ln x plus 3. Now, remember what we said. If you leave it like this, you won't get your full answer. Your full marks. Because we know that if you get to this point, we're given the value of y. And since we are given the value of y, what is y? Y is this one here. So then we substitute it here, back here. So this is dy over dx, which is equals to x to the power of 3x times 3 ln of x plus 3. Are we all together?
Yes, ma'am.
Yes.
One last
Yes.
Thank you. Now we're going to skip the exercises for now because I want us to cover the work. Now we go to successive differentiation, right? Here, what they mean is they want you to know to find the first derivative, the second derivative, and even the infinite derivative. I can ask you derivative number 100. Just be alert. So that is page 32. Now, on page 32, they are telling you that if you differentiate, so if you have a function, for example, they're telling you that if you have a function y, so they're saying if you have a function y equals to 3x squared plus 2x plus 5, and they ask you to find dy over dx, we know this will be 6x plus what? Plus 2. Now, if they ask you to find the second derivative, so this will be d squared y over dx squared. So this will be equals to 6, right? If they ask you to find the third derivative and so on. So at some point, some derivative, they stop. You understand? Look at this one. Then the third derivative, dx squared is equals to 0. After that, the derivative of 0, it keeps on being 0, 0, 0, 0. Are we all together?
Yes.
Yes, ma'am.
Now, they're saying that some of them don't become 0. You can differentiate as many times, you'll still get an answer. For example, if you differentiate cos and sine, you still get an answer, but there will be some pattern with some differentiation. Are we all with some functions? Are we all together there? Now,
Yes, ma'am.
they are telling you that
Yep.
please do not confuse dn dy over dxn with this. This is an nth derivative, and this is the first derivative to the power of nth. Are we all together? Right?
Yes, ma'am.
Thank you.
Ma'am. Yes, ma'am.
Yes. Okay. Thank you. Now, let's differentiate this. Y is equals to 10, 3x, and they want you to find the third derivative, which they sometimes write it as f of prime, 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 x. Can you differentiate that? Can we differentiate that? I need help. Guys, I need help with that one. Let's differentiate that. Hello? Hello? Guys, we need to cover the what's this? The notes and then come back to the exercises. And if we keep quiet, then where do we start? Or are we all okay with this one? I can skip.
The first derivative is gonna be
Mhm.
x squared 3x.
So it's going to be what? Sorry. dy over dx is equals to? Say it will be what?
Sec squared
Sec squared.
3x.
3x
3x times 3.
Yes.
multiplied by 3.
Okay.
Which is good.
So it's 3 sec squared 3x. Is there anyone who doesn't understand how they got it? Guys, don't be shy. Trust me, don't be shy. Should I explain?
Yes.
Okay. Now let's go back to page 2 of the study guide. Page 2 of the study guide. Are we there? Are we there on page 2 of the study guide, guys? Where it says standard differentiation coefficients, the ones we learned last week. They're on page
Yes,
2 of the study guide. They say that it's number 1, 2, 3, 4, 5, 6, 7, 8, 9. What's this? Row number 9. They say tan, or if you have the function tan of f of x, then the derivative will be sec squared of that function f of x times the derivative of f of x. That's what they're saying. So it's what we have in our notes. So meaning that our function here, f of x, is what? Is 3x. So then the derivative of this, the first derivative, will be equals to sec the function. So that's sec squared. The function, in this case, is 3x times the derivative of the function, which is 3. That's how we got 3 sec squared 3x. Are we all together there?
Yes, ma'am.
3 yeses, please.
Yes, ma'am.
Yes, ma'am.
Thank you. Now they want us to go and find the second derivative. When you find the second derivative, you now look here. This is where you look. So let's write this. So the first derivative is dy over dx, which is equals to 3 sec squared 3x. Now you go back to the same table on page 2 and go find sec, what's this? Go find sec f of x. Do you see you don't have sec squared of f of x? Guys, are we all together?
Yes.
Thank you.
Yes, ma'am.
Meaning that this can be written as 3 sec 3x squared. Are we together there?
Yes.
Thank you. Now, from here, which rule are we using? Which rule are we using here? Guys? Which rule are we using?
Power rule.
The power rule.
Yes.
Chain rule.
Chain rule.
Thank you. There's a chain. Now the chain rule, which one is the which one is the inside function? Which one is the outside function in this case? Or give me the
Inside
answer.
is 3.
Yes. Inside is what?
3x.
3x. So let's, okay, since you say inside, differentiate this function for me. So this is the second derivative over dx. Differentiate this function for me. You'll have
You'll have 3
3
multiplied by 2.
multiplied by 2
Sec 3x.
sec 3x.
Then you will have that multiplied by sec
Sec
3x
3x
multiplied by
Times
10
multiplied by 10
3x
3x
multiplied by 3.
multiplied by 3. Okay, thank you. Now, one can ask, how was this found? So let's do that. Let's explain it. From here, we notice that we're supposed to use the chain rule, right? So let's use that chain rule. So we know that d of the second derivative of y is equals to, so this is 3 times these 2. So times 2, the outside function, isn't it? Because we're using the chain rule, times sec of 3x, 2 minus 1. Now times the derivative of this sec 3x. Do you see that? Now, if we go back to our table on page 2, they say the derivative of sec x, in this case, let's say f of x, is equals to sec, this is on page 2, times 10 of x times the derivative of the function of f of x. Now the derivative in this case is what? Our function in this case is 3x. So f of x is equals to 3x. So meaning that the derivative, this function here, of sec 3x is equals to sec f of x, in this case is 3x, times 10 f of x, in this case is 3x, times the derivative of f of x. Our f of x is 3x, so the derivative is 3. So 3. So then this is equals to 3 sec 3x times 10, 3x. We then take it and substitute it in here. So therefore, d squared y over dx squared is equals to, so that is, what is this? This is 2 times 3, that is what? 6 times 3, that's 18. So this is 18 sec 3x times sec 3x times 10, 3x. Are we all together there? Guys?
Yes, ma'am.
Thank you. So this is equals, let's simplify, 18 sec squared 3x times 10, 3x. Are we all okay up to here?
Yes, ma'am.
Thank you.
Yes.
Now, okay, let me make a new page. So we said the second derivative, dy over dx squared is equals to 18 sec squared 3x times 10, 3x. What do you think we can do from here? Guys, what do you think we can do from here? Anyone? What do you think we will
We
do
go-
from here?
We go by the third derivative, ma'am.
So we go by the third derivative. How are you going to find the third derivative? So this is d. Give me the answer for the third derivative by looking at it.
Since we don't have a derivative for sec squared, we're gonna do that. We do what we did last.
Okay. So you're saying let's simplify the top first. So
and
you're
do the
saying,
chain.
okay, so you're saying 18 sec square, 3x squared times 10, 3x. That's what you're saying.
Yes, ma'am, and then do chain rule.
Okay, hold it there. Can someone say something?
Oh,
I
we're
know
gonna use
someone
the
wants to say-
product rule,
I
man.
think I think we have a product rule there, and
Why?
we have a multiplication between them.
Thank you. We'll use the what? The
Product
product rule. Thank you very much. Do you understand why we're not using the chain rule, isn't it? We are going to
Yes,
use the
ma'am.
product. But when we are differentiating, there's some form of a chain rule here. Because when we're going to differentiate this function, go. What am I doing? Hey. Choose yellow. Here, that's when the product rule apply when differentiating. Can someone say something? Guys, you know when you're differentiating, it's easy to see now what you're doing because you know we're doing what's this? Successive differentiation. But when you have all of them in the exam, it's not, you see people are getting totals in the assignment. When they get to the exam, they are not getting the totals because you are unable to identify what you're supposed to use and which one is easier to use. If they don't state which method to use, which one is easier to use? And remember, you can't do magic without learning the tricks. And when you're doing the exercises, you'll be learning some of the tricks. What else? I'm not saying don't do the product rule. Do it. It's fine. Do it. It's fine. But there's something here, guys. Can someone say something? Let's not use the product rule. Let's use something else.
The log identities.
The what?
Identities. I was saying
The I? Which identity? Which identity?
like 3x squared 10 to 1 plus 10 squared 3x.
Thank you. Guys, it's important that you're dealing with, because you're dealing with trigonometric functions, right? Remember your identities. They will also help you to simplify. Remember when you have sine squared x plus cos squared x, it will be equals to 1. And when you have 1 plus tan squared x, you'll get sec squared x. Do you remember those identities? Yes, no?
Yes.
Yes, ma'am.
Yes, ma'am.
It's important you remember those. Your sine over cos x, that is your tan x. Your cot of x, which is your cos over those things. Just remember them. Just put them in mind, because then they'll make you, they'll simplify your life easier. So you'll go, okay, for now, your homework is you'll go and use the product rule that you wanted to use and see if it will be very quicker to do what? To simplify that. Instead, what you can do is you can change this one into 1 plus 10 squared 3x times tan 3x. So then you have 18 10 3x plus 18 10 to the power of 3 3x. Do you see that?
Yes, ma'am.
I need 3 yeses. So we use the identity here. It's an existing identity. It's not something new. So from here, we can then say the third derivative is equals to what? Let's go back to page 2. We know if we differentiate tan, the derivative of d over dx of the function tan f of x is equals to what? They say it's sec squared f of x times f of prime of x. In this case, our f of x is 3. So f of x is equals to 3. So then our answer here, the first one, will be 18. Okay, let me choose the red color just to be for consistency. So this will be 18, the derivative sec squared of 3x times 3 plus. Now, this one, we could have written it as 18 tan 3x plus 18 in brackets tan 3x to the power of 3. Are we all together there? Yes,
Yes,
no?
ma'am.
Thank you. So meaning this will be 18 times differentiate. Here it's the chain rule. So it's 3 tan 3x to the power of 3 minus 1 times the derivative of this. And we know the derivative of this, which is this one over here. So which is sec squared 3x times 3. Are we all together?
Yes,
Yes,
ma'am.
ma'am.
Thank you.
Yes.
So this is equal
Yes,
to, what's the answer? 18 times 3 is what? 18 times 3.
It's 54.
54.
Thank you. 54. So that's 54 sec squared 3x plus times 3, 162 sec squared 3x times, okay, we forgot about this, times 10 squared 3x. So let's write it neatly. This is 54 sec squared 3x plus 162 sec squared 3x times 10 squared 3x. Go back to the answer, and that's what we got. Are we all together now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Thank you. Okay, we're going to skip going forward, and then we're going to do some exercises. Now, we're going to differentiate. This is called inverse trigonometric differentiation. Right? Now, with inverse trigonometric differentiation, there's a note there. So you're going to read all of that, and there's a note there that they say we use sine. Do you remember in your calculator you have something like this? Do you remember what is this exactly, guys? Eh? The x sign. Do you remember the x sign? For example, they said find the angle cos A, and they tell you maybe this is what, 0,2, and then you say A is equals to cos something like this. Remember what you used to do when you were grade 10, 11, and 12?
Yes, ma'am.
Thank you.
Yes,
This is what we are using. This one here. That's what we are using even here. So now we want to find the derivative of that. So they are saying that if you say sine, arc sine like this, right? This is not equals to 1 over sine x. Please don't confuse that. And they say this one, we call it the arc sine of x, right? Now, how are we going to represent an inverse in this work? That we're going to represent it like this. Do you see the two different stuff we have? This is not the same as this. This is not the same as that. Okay. Now, I guess it's easier to see the inverses, isn't it, guys? Compared to any other. You can't use logarithmic differentiation. Okay, you can use if there's a combination of a lot of functions and an arc function and whatsoever. But in this case, we're going to use the inverse differentiation because differentiation of inverse trigonometric function. That's what we are using here. So, how are we going to do this? We are told that if we given a function, let's look at page 42. They say if we're given a function, let's say arc sine of f of x. This is the function that we are given. And then the derivative of this function is the inside function f of x, right? The derivative of the inside function f of x divided by the square root of 1 minus f of x squared. Do you see here the inside function is very important? Guys, do you see how the inside function is very important here?
yes, ma'am.
Yes, ma'am.
Thank you. So that page continues. If we are given a cos, then the derivative is on the right hand side. So let's do an example. Example 1 on page 42. 2. So this is example 1. Sorry about that. So example 1. So with example 1, you have y is equals to arc cosec of 1 plus x squared. And they ask you to find dy over dx. Where do we start? Guys, where do we start? Where do we start? Anyone? Where do we start here?
I think we identify fx, ma'am, the function on the inside. Fx is equal to 1 plus x squared.
Thank you. So fx is equals to 1 plus x squared. Then,
Then we find the derivative.
okay. So we then find the derivative. Where are we going to find the derivative? So just note, it's not necessary for you guys to be able to prove the general derivatives that are on page 42. You just have to make sure you memorize them, you see them, you understand them, and you are able to apply them. So the arc cosec is given by what, according to page 42?
It's minus f prime of x.
So let's write that arc cosec of f of x, the derivative is what? Minus f prime of x,
Divide by
divide by
f of x square root bracket f of x to the power of 2.
Thank you. So this is something that is on page 42 of your study guide. All together. Guys, one tip, it's important that you understand the work, right? Because when you understand the work, then you can be able to tackle any question. Now, if you understand the work, do the exercises and do the example. Then you also learn some few tricks that are within the examples themselves that will help you to understand the work. Are we all together?
Yes, ma'am.
Thank you. Now, how are we going to do this, guys? We have identified our f of x. You can either go straight and substitute, or you can do the things outside and then substitute. Whichever works for you, it's still fine. Now, for example, on the derivative, so let's write, we're looking for dy over dx. They say minus, what is the derivative? Our f of x is 1 plus x squared. What is our derivative? Our derivative, please don't forget this minus. Hey, we tend to forget it. I once forgot it as well. This minus, don't forget it, right? So what is the derivative of this function? I always put the derivative in brackets. So that is 2x. Are we all together there?
Yes, ma'am.
Divide
Yes, ma'am.
by f of x. You see how easy it is to just multiply if you understand x squared. Take the square root. That's what they are saying here. Take the square root of f of x and square it. So that is 1 plus x squared, then square it, then minus 1. Then you simplify. So let's simplify. So this is equals to minus 2x over 1 plus x squared. Simplify inside here. So this is 1 plus 2x squared plus 2, okay, 2x to the power of 4 minus 1. Are we all together?
Yes, ma'am.
With this one in here, can I please ask, are there people who are still doing this? 1 plus x squared times 1 plus x squared. And then they multiply like this. Are there people who are still, it's not wrong, but are there people who are still doing that now in this group? Yes or no? I need to know. Me, I like saving time. That's why I'm asking. Are there people who are saying 1 times 1 is 1 plus? There's nothing wrong, but you can save time by looking at the bracket and doing. Are you one of those people? Yes. If there's a yes, then I will explain how I do it. If there's a no, then it means we all on the same page.
Yes and no, ma'am.
Sorry, ma'am. Isn't
Yes
it
and
just
no.
supposed to be x to the power of 4?
Isn't just supposed to be x to the power of 4? I
Is
don't
that your
understand.
question?
Oh, yes, sorry. Thank you. Thank you. Okay, let's go back. You're saying what? There's a yes and a no.
You see, ma'am, that is why I'm saying it's yes and no, because if I don't know how can I explain it, but like just to be sure. Sometimes you can be wrong because you attempted using shortcuts, but if you do it aside, then you'll see that okay, I'm getting a correct answer.
So the shortcut, because me, this is how I normally do it. And okay, like this, right? I don't open brackets. I say you first square the first term, ne? Take it the way it is with its sign and square it. Then you say plus times this, 2 times this times that. So it's 2 times x squared times 1. Then it's what? 2x squared. Then you square the last term the way it is with its sign. Plus, that's what? That's to the power of 4. So that's how I do it. So that's how it's quicker. Because I noticed, when I was looking at some of the, some of the last year's exam, there were people who did this on the side. 1 plus x squared, 1 plus x squared. You see, and then they had the whole expression and whatsoever in there. Because sometimes we're just trying to avoid errors. The more you have, the more error, the more chances you get. You're bound to make errors. You're bound to make errors. Okay, so let's continue then. This is equals to minus 2x over 1 plus x squared. This one minus that one, so you have square root of 2x squared plus x to the power of 4. Okay, we can still factorize, so this is equals to minus 2. We can still simplify. Then it's 1 plus x squared. Now inside here, you'll notice that we can take out x squared. So this will be x squared. Then we'll have root 2 plus x squared. Are we all together there?
Yes, ma'am.
I need 3 yeses.
Yes, ma'am.
Last yes.
Yes, ma'am.
Yes,
Yes.
Now remember that a times b under the square root is the same as a square root of a times square root of b. So meaning that we can split these two, this one and that one. So minus 2x over 1 plus x squared, square root of x squared times square root of 2 plus x squared. And we know that square root of x squared will just be equals to x squared to the power of half. So this will be equals to x. So meaning that this is equals to minus 2x over 1 plus x squared, x times square root of 2 plus x squared. Then this x cancels. They do not cancel, they form a 1. So this is minus 2 over 1 plus x squared, square root of x squared plus 2. Are we all together? Guys? Hello?
Yes,
Did I
ma'am.
lose
Yeah.
someone?
Yes, ma'am.
So that's the work we're covering today. Did I lose someone? Yes, no?
No.
Okay. So we did logarithmic differentiation. We did successive differentiation, and then we did differentiation of inverse trigonometric functions. Is there something that you guys didn't understand from the three? Can you? Okay, the other one is just repeatedly differentiating something. Find the second derivative, finding the third derivative. But the other two, the logarithmic differentiation and the inverse of trigonometric functions. Are we all okay there?
Yes, ma'am.
Okay,
Yes, ma'am.
thank you. Now, you see with example 2, I think example 2 is one of the examples that we did previously. Example 2. So we're going back to look. So we're going to do some few examples until time, right? So now, it's one of the examples I think we did last week, but we used a different method. Do you remember that one, guys? Yes, no? Yes or no? I'm not hearing anyone saying anything. Do you remember it or you don't remember it? I think it's number 3. Exercise number 3 or example number 3. What is this? It's activity number 2 on page 5. Did you do that? And which method did you use? Which method did you?
Activity number?
Activity number 2, activity number 2, question number 3, page 5 of the study guide. Which method did you use to solve that one?
Quotient.
Quotient rule, right?
Yes.
So now, in this case, okay, which other method can you use to solve that one?
The product rule?
You can use the product rule.
Can you go and try the product rule as your homework and see what happens? And then which method can you use that to solve that one as well? Which one do you think is easier to solve that one?
Logarithmic differentiation.
Thank you, logarithmic differentiation. Do you see that? You
Yes.
look at the question, if you're not told which one to use, go for the easiest one. We have mentioned that you can use the quotient rule. So in the exhibits, they use the quotient rule, right? Then you can also use the product rule where you simplify the brackets and whatsoever, right? But then you might have a problem because inside there's a quotient again. When you differentiate that, it will require you to do a quotient rule. So meaning that, let's see if logarithmic will be easier compared to what the other one has. So we have y. So y is equals to the square root of 1 plus x over 1 minus x. Right? Now logarithmic differentiation says we ln both sides. So we take the ln, both sides. So 1x over 1 minus x. Now we start to simplify. We know that if we have the square root of a, this is the same as a to the power of half, right? So let's do that. So this is ln of y equals to ln of 1 plus x over 1 minus x. Do you see, guys, every step I think about it on what I'm supposed to do. Trust me, I've seen some people just writing and writing and writing and writing. You think, what's the next step? Okay, the next step, I see this rule. This is what I'm seeing in my next step. Ln of a to the power of n. So it means I can write it as n ln of a. Okay, let's do that. So this is equals to 1 over 2 ln of 1 plus x over 1 minus x. What's my next step? I see. What's my next step, guys? What's my next step here? Because remember, step by step, you need to think, what's the logic step, mathematically correct step that I need to do?
We have the law ln open brackets a over b.
Thank you. Here we have the top and the bottom. So we have a over b. So this is ln of a minus ln of b. Sorry. Yes, it is that. I don't know where my brain is. It is that. So this is equals to, now be careful, guys. You have 1 over 2 brackets ln of 1 plus x over 1 minus x. Trust me, it might look like it's not hard, but people forget during the exams. I don't know what's going on. Maybe it's the pressure, or maybe it's the time, or maybe I don't know what's going on. The anxiety, I don't know. So then this is 1 over 2 open brackets. People forget to open the brackets and multiply everything by this half with everything. So this is ln 1 plus x minus ln of 1 minus x. Are we all together there?
Yes, ma'am.
So therefore,
Yes.
we have ln y is equals to 1 over 2 brackets ln of 1 plus x minus ln 1 minus x. From here, we now differentiate both sides. So this is 1 over y times the derivative of y is 1 times, since we differentiated y, we have to multiply by dy over dx. This is equals to 1 over 2, 1 over inner function 1 plus x times the derivative of the inner function. In this case, it's 0 plus 1 minus 1 over the inner function 1 minus x times the derivative of the inner function, which is 0 minus 1. Then this is equals to 1 over y dy over dx equals to 1 over 2. This is 1 over 1 plus x. Now, because there's a negative here, this becomes 1 plus 1 over 1 minus x. Are we all together there?
Yes, ma'am.
So dy over dx, let's multiply y both sides. We have 1 over 2y. Then we have 1 over 1 plus x plus 1 over 1 minus x. Leave it like this. You will not get your full marks. So what do we do here? We simplify. Okay, Let's add those two. Do you remember how to add them, guys?
Yes,
Hmm?
ma'am.
Okay, thank you. Give me an answer for that one. So we are adding, let's put a block here. Just to remember how we add. So we have 1 over 1 plus x plus 1 over 1 minus x. This is equals to what?
We look for a common denominator.
So what is the common denominator?
Our common denominator is open brackets 1 plus x.
So let's say common denominator, it's open bracket 1 plus x. Yes.
And then close open brackets 1 minus x.
1 minus x. Okay, then.
Okay, so that is our common denominator. Then we say 1 plus x into our denominator. We have 1 minus x.
So you're saying here we have 1 minus x on top.
Yes.
1 minus x. Mm-hmm.
And then we say plus.
Plus.
And then 1 minus x into a common denominator, we have 1 plus x.
1 plus x. Mm-hmm.
Then we simplify.
We say over, or we just leave it like this?
Yes, over our common denominator.
Guys, thank you. Is there anyone who's like, I don't know how the common denominator was found. I really don't know. And yeah. Guys, it's easy to forget this because you remember you cover it in your lower grade. Do we all remember?
Yes.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes.
So meaning that if we have 3 of them or 4 of those, we'll remember, oh, the common denominator is this, therefore we do that.
Yes, ma'am.
Should I write the answer or also explain my part? Guys?
Explain your pattern. Explain.
Okay. So this is the answer. This is what, well done. Thank you very much. Now, one thing I'll tell you, I used to struggle with this whole find the denominator, like how you did it when we started fractions was a grade 9. So I used to struggle with that to a point where I had to see if there are other ways of doing it. You see. So this is how I did it. And I find it more easier for me. Because sometimes it's not easy to just look and find the denominator. So I'll say 1 over 1 plus x plus 1 over 1 minus x, right? Okay. Let's do this before we get there. Let's go back to fractions. We know that 1 over 2 plus 1 over 3, they cannot easily be added, isn't it? Because if you're not using the calculator, the denominators are not the same. So you make the denominators the same so that you can do what? You can be able to add. You can only add the numerators if the denominators are the same. So this is how I used to do it. I'll take this denominator, right? Multiply it this side with half. So this is 1 over 2 times 3 over 3 plus, I'll take this denominator, multiply it this side. So this is 1 over 3 times 2 over 2. Do you see that, guys? Do you see what I just did?
Yes, ma'am.
Thank you. So then this became 3 over 6 plus this became 2 over 6. Then it was easy for me to say, okay, fine, since the denominators are the same, I take it the way it is. So then it will be 6 here. And then I add these two. Then it's 3 plus 2, which is equals to 5 over 6. That's how I would use that's how I would find using until I got it at a later stage of saying put 6, divide by 6, multiply by 4 and whatsoever. Now, I've used this for a long time. Even now, it's working for me, right? Meaning that if you have something like this, you do the same. So you have 1 over 1 plus x. I take this denominator here, multiply it here. So this will be 1 minus x over 1 minus x. We know 1 minus x over 1 minus x is equals to 1, right? Plus, I put this one the way it is, so it's 1 over 1 minus x times this denominator here. 1 plus x over 1 plus x. So then this will be equals to 1 minus x over 1 plus x, 1 minus x, plus 1 plus x over 1 minus x, 1 plus x. Do you see that? Guys, are we all together?
Yes, ma'am.
Yes,
So
ma'am.
that's
Yeah.
how I found my denominator, meaning that now I can add, this is now my lowest common denominator, meaning that I can now add the top part given this denominator is like that. I hope this will help those who also struggled like how I struggled to write it. So meaning that this will be equals to 1 over 2y, 1 over 2y. Remember, the denominators are the same, so we take the denominator the way it is. So this is, let's put it there. So this is, okay, what's going on now? This is 1. Okay, what's going on with this pen? Sorry about that. So this is 1 plus x, 1 minus x, right? Because the denominators are the same, you put it like that. And then you add the numerators. So this will be equals to 1 minus x plus 1 plus x. So let's remove this, our rough work. Now this will then be equals to 1 over 2y. This x cancels that x. So this is what? This is 2 over. Can we simplify that now?
It's
Okay,
1 minus
before.
1 minus x squared.
Thank you. Thank you. So this is 1 minus x squared. Are we done?
No, ma'am.
Why?
No, we must substitute 1.
Thank you. We substitute y. So therefore, this will be equals to dy over dx equals to 1 over 2. Our y was a square root of 1 plus x over 1 minus x. Okay, I just like putting in brackets. So this is 2 over 1 minus x squared. Are we all together there?
Yes, ma'am.
Thank you.
Yes, ma'am.
So let's go now to successive differentiation, example 2. Remember, we are skipping. As long as we know what we are doing, now we're going to the examples. So example 2. In example 2, they give you z is equals to xy. Now, and listen, and y is a function of x. When they say y is a function of x, what do they mean when we're going to differentiate? Guys? They say and y is a function of x. What do they mean? What do you think they mean? What is the meaning of that? Hello? What is the meaning?
It means it's not a constant. Huh?
Okay, I have 2 answers. Can I please have the first answer and the second answer? The first answer.
It's not a constant, ma'am. There's two functions.
Okay. And then the second answer. I had a second answer.
I think we have an inner function.
Okay. Justify the first answer.
It's a product, ma'am.
Okay. Okay, it's not a constant, it's correct. But you can't say it's a, okay, you can't say it's a product, right? When they say that, remember, when you are differentiating, you're going to differentiate Z with respect to what?
Z, I think.
No, you're going to differentiate Z with respect to what? What's the question?
To X.
X.
To X, right? So if they say Y is a function of X, it means it's not a constant, it's a function of a what? Or of X. So when I differentiate Y, what am I supposed to do?
Implicit differentiation?
Thank you. Not implicit differentiation, but we need to remember the implicit behavior. Don't confuse implicit differentiation and implicit behavior. Right? Remember implicit differentiation, we had to take Y to the other side and differentiate, and then after take the other things to the other side. But then with logarithmic, we perform some form of implicit behavior that we have from implicit differentiation, that when you differentiate Y, because Y is a function of X, when you're going to differentiate it, multiply by the derivative of what? Of Y with respect to X. So every time when they say Y is a function of X, multiply it with a derivative with respect to X, dy over dx, basically. Are we all together there?
Yes, ma'am.
Thank you.
Yes, ma'am.
Because I'm not sure if we are doing partial differentiation, but if we are doing partial differentiation, let me see. Looks like we're not. We are doing partial differentiation, unit 11, and you see why. What is the difference? Because then okay, I'll explain the difference then later, or I can just explain it now. Because with partial, one of them becomes a constant; it just disappears. Do you see that? But here, one of them will not disappear because Y is a function of X. And remind me when we do partial to come back to this question. So now, they want us to find dz over dx, and they want us to find d squared z over dx squared. So let's differentiate. Can I please have the derivative of z with respect to x? So this is the derivative. How do you read this? The derivative of z with respect to x. Differentiating z with respect to x. That's what you're saying here. Okay. Can I please have an answer to this? Which rule are we applying here?
The product rule.
The product rule.
Thank you. So can I please have the answer?
It's X times 1 dy dx dz dx
Times dz dx
plus
plus
y times 1.
times 1. Thank you. So how did we get this? Thank you very much. So how did we get this? We first differentiated, okay, we first differentiated the first one. The first here is what? Is x. So the derivative of x is 1 times y, plus we can always do the other way around, differentiate the second function first, then whatever, right? And then we differentiate the plus, differentiate the second function, leave the first function the way it is. Our first function is x, so we're leaving it the way it is. And the derivative of y, we know it's 1. But because we differentiated y and y is a function of x, we multiply by what's this? dz dy. I mean, what am I saying? dy dx. We multiply by dy over dx. Are we all together?
Yes, ma'am.
Thank you. So meaning
Yes,
that
ma'am.
this is y plus x dy over dx. Now, okay, this is the first derivative. Now they want us to find the second derivative. So it's d squared z over dx squared. Please help me. What is the first one? Here. What will be here? When we differentiate this is what? Guys?
dy
dx.
Thank you. The derivative of y is 1. We all know. But because we differentiated y with respect to our masters, and y is with respect to x, so this will be multiplied by dy dx. Are we all together?
Yes, ma'am.
Yes.
Thank you. Plus here. Now we can see this is a product of two functions. It's product of x times dy over dx. So meaning that we're going to use the product rule. So the product rule says leave the second function the way it is and differentiate the first function. Our first function here is x, so the derivative of x is 1 times the second function is dy over dx. Are we together? Plus, leave the second function the way it is, so that is x times, if you first find the derivative of dy, this is the first derivative of dy. The second derivative of dy over dx would just be dy second derivative represented by this. Now, we can see here we have dy over dx plus dy over dx plus x d squared y over dx squared, which means the second derivative of y with respect to x. So this is 2 dy over dx plus x second derivative of y with respect to x. Are we all together?
Yes, ma'am.
Yes.
Yes,
Yes,
ma'am.
ma'am.
I'll skip. We go to, sorry, logarithmic differentiate. Do we still have time? I think time is up. Can I trust you to go and do the remaining exercises and examples? If you have a question, tell me. Otherwise, I'll do a recording. So, for example, guys, if you have a question on example 2 and you don't know how they found step number 5, you'll go to step number 5. You'll send me an email and say example 2, page 3, step number 5. I don't understand 1, 2, 3. This is what I did. And then if I have time, I'll call you. If I don't have time, and sometimes if I see that some people will also want to benefit, I can do a recording of that particular example and then upload it so that you watch it. Is that okay? Because I think we have a very short time to cover all the exercises. And I want us to cover the work for the whole assignment 1. Is that clear, guys?
Yes.
Yes.
Okay.
Yes.
So do you guys understand the work? Now, the work that we covered, yes? Zinhle, I see a hand. Unless the
Oh,
hand.
yes, ma'am. I wanted to ask. I have a question on implicit differentiation, right? So on the study guide, the post-test, I don't know if maybe you can like do it separately or what, but the post-test number 6, I got stuck.
Test number 6. Okay,
Yes.
no problem. So should I record a video on it?
Yes, ma'am, you can.
Okay, I'll do that.
Okay, thank
I'll
you.
do that. You're welcome. Good. Any other question, guys? I think we can stop the recording.
Ma'am, I have a question, please.
Yes.
It's with regards to page